finite state machines can do a lot more than just detect a single sequence of ones and zeros. In this series of examples, I'll show you more complex designs and I'll walk you through how I actually go through the design process itself. So example 1 asks me to design a finite state machine with one input X and one mealy output Y. And the output should be only asserted, that output Y should be only asserted when it detects either of the following sequences, either 0, 1, 0 or 1, 0, 0, 1. So I'm not designing two separate states or finite state machines. I'm designing a single finite state machine that can detect either of them, either of two sequences in overlap. So I will allow overlapping in here. So I'm going to make that assumption, meaning I'm not going to reset after I detect one of the sequences. That means like if you say 0, 1, 0, and then 1, and then 0, or something like that, I'm going to detect it. So in here, I'm showing you in this table some examples so that we can see how it works. For example, I'm going to detect all the sequences that are 0, 1, 0. I think there's a 1 here. That outputs this one. There's another overlap in here, or an overlap in here, so that will output this one. And I have that one here. This will output this one. And I will leave this one here. And that's it for the 0, 1, 0. For another sequence in here, for example, the one here, I'm going to show in pink. That should be 1, 0, 0, 1. I believe this one is in here. And there you go. That's this output. And I believe there should be another one in here. And that's all the outputs. Yes, I accounted for all the outputs, ones and zeros. So as you can see, I'm detecting a couple of sequences, and that output Y will tell me, well, it matches this one or it matches this one. With overlapping allowed, as you can see in here, there's an overlap in here, and there's a bunch of overlap in here as well. So let's go through the process of this design. And again, I'm designing a mealy project or a mealy output in here. So let's get started. So I'm going to write these two sequences that I'm looking for. So I'm looking for a sequence which is 0, 1, 0, and the other sequence I'm looking for is 1, 0, 0, 1. Those are the two sequences I'm looking for. So usually the very first thing I start with is some sort of a reset state. So for example, I can say, okay, here's a reset state that's S0, and I usually indicate it with some sort of an arrow. And I'll just write it here for my record. So I'm going to say, well, S0 should be equivalent to some reset, for example. Okay, so that's the state, and that's what it means. It's the reset state. So now I'm looking, I usually look for one of the, if I have two sequences that I need to actually match, I usually build one for one sequence, and then I look at these states that I just built and try to reutilize some of the states that I already created. So let me walk you through this example. So first I'm going to say, well, I'm going to detect 0 followed by 1 followed by 0. So let's do this. So the very first thing I'm going to do is I'm going to say, okay, let me create another state in here. And this state here I'm going to call S1. And this S1 will be to reach from the reset state whenever we see 0. And of course, whenever we see 0, we haven't met any sequence we want yet, so the output will be 0. Since it's a mealy output, I'm going to indicate it on the transition lines. So in here, I can write the S1 remembers sequence 0. And then I'm interested in this one here, the 1. So I'm going to create another state in here, and that state here I'm going to call S2. And S2 is just going to be transitioned from S1 whenever you see a 1, and the output should be 0 because we haven't seen a full sequence that we care about yet. And then the last one here is I will actually create some state. I'm going to call it S3. Okay, so here's S3, and of course we usually reach this here, or we want to reach it whenever the output here or the input is 0, and of course the output in here, which I'm going to indicate in red so that we can see it clearly, is actually 1. All right, so again, so you see a 0 followed by 1 followed by 0, and that will indicate that there's a 1, or I need to output a 1. Of course, I need to write here, I believe I forgot to write the S2 is 0 followed by 1, and S3 is detecting 0, 1, 0, and this is one of the states that I care about, so I'm just going to highlight it here. That's actually outputting a 1. And I believe this particular one here, technically I can be done with it if I was actually just looking for this particular sequence. I'll just have to make sure that all the states have enough outputs. For example, in here S1, I just accounted for whenever the input is 1, what happens if the output is 0. So I can of course account for that. Now we can move on to the next state, but before I do this, I just want to make sure that because overlapping is allowed, so I want to make sure that I'm accounting for this. For example, if you see 0, I want it to be counted, and followed by 1, followed by 0, I want to see an output. So I'm saying, like, let's see this output in here. So based on S3 in here, let's assume that you do get an output that is a 1. So what I want to do is I want to remember that I've seen a 0, 1. So 0 followed by 1. So technically all you have to do is just do this here. So what I'm saying in here is the following. So S3 is remembering 0, 1, 0. And then what if a 1 came after it? Well, that's a 0, 1. So I'm just going to go to S2 and just reutilize it. So that shows me the following. If you get 0 followed by 1 followed by 0, you're going to get that output 1 here. So I counted for the overlap in this case. All right, so now let's move into the next sequence in here. I'm just going to indicate it in green. Okay, so this sequence in here, which is that one here. So I'm going to start from the same exact reset state, and I'll go through it. So the first state I want to do is remember a 1. I'm taking a look at these states in here. I don't see anything that only remembers a 1, so I'll create its own state in here. So let's say that I want to create this particular state here, and I'm going to call it S4. And you usually reach S4 from S0 whenever the input is 1, and the output, of course, will be 0. All right. So now the next, I'm going to write it in here. So S4, just remember 1. And then what if 0 came afterwards? Well, 1 followed by a 0. Well, it's partially here. It's not fully, but partially here. So maybe I can modify the S3 so that I'm going to consider it as if it remembers 1 followed by a 0. So it's remembering a 1 followed by a 0, or a 1 followed by a 0. So I can consider S3 not only like it sees 0 followed by 1 followed by a 0. I can just consider it that's a 1 followed by a 0, or 1 followed by a 0. So that will help me and will allow me to actually do the following in here. So you see that here? So now I can say, well, after S4, if I got a 1 and then I follow by a 0, the output will still 0. So I can basically detect this second one, and I was able to reutilize S3. So that's the beauty of building finite state machines, that actually can reuse some of the states that we already created. I didn't have to do this. I would have been able to create just completely different state and just go from there. But I just wanted to show you that I can actually do this, and this is doable. All right, so we're going to continue the sequence. We have detected a 1 followed by a 0, and then all I need is actually a 0 followed by a 0. I don't see anything that is a 0 followed by a 0. So I'm going to have to create a new state in here, and that state in here is going to be S5. So let's do that here. So this is S5, and I'll translate from it, or transfer to it from 0, and the output will be 0. So now S5 can be considered as, I believe, you can think about it as 1 followed by 0 followed by 0, or just a 0 followed by 0, since I don't have either of them. Let's consider it a 0 after a 0. All right. So that's good here. So I'm not done yet. So I detected 1 followed by a 0 followed by a 0. So what I need to do is I need to figure out some 0 followed by 1. And really, 0 followed by 1, I think we have it. It's actually S2. So I can just reutilize this, and I'm just going to say, well, why don't you just do this here whenever you get a 1? And of course, the output here should be a 1 because I just detected that sequence at this point. All right, so what have I done? Well, I just was able to create this particular sequence, 1 followed by a 0, and then followed by another 0 followed by a 1. Okay, and that outputted a 1. Okay, so that's good. I can, of course, start it from here. Let's assume that we got a 1 followed by a 0, followed by a 0, followed by a 1. So that's also good. So that's that utilizing S3, or just making it remember that, or mean that it actually saw a 1 followed by 0, helped a lot. And I was able now to reutilize, as you can see, the intersection between the green and the blue. I was able to reutilize this state and reutilize this state. This is kind of completely for the first sequence, and this is kind of completely for the second sequence. Of course, I'm not completely done yet. I'll have to complete the state graphs just to make sure that everything is there, like all the states have like the zeros and ones. So I will just do that in here. All right, so S0, now I do have the S0 leaving the 0 or 1, so I'm done with S0. For S1, I'll say, okay, well, S1 remembers a 0, so whenever you get a 0, I'll just say, well, just keep at it, just stay at S1. And now I'm going to go to S2 in here. I believe I have an arrow leaving it when it's a 0. How about when it's a 1? Well, when it is a 1, we're going to have to think about it here. Let me just see. So if it's S2 is here, I need basically 1 followed by a 1. Do I have anything that is a 1 followed by a 1? No, not really, but I can just say, well, it's just a 1, a single 1. And if I'm taking a look at those, I can just now just modify the S4 so that it just remembers that it's a 1, and I can just do this here. It's just a reutilization. I didn't have to do it that way, but I can. So what I'm doing now is I'm saying S4 just remembers a 1. So it starts from here. It just remembers a 1 or just remembers a 1. So it doesn't remember a 1 followed by a 0 or something like this. I don't know why I wrote that 0. I don't remember it. But anyway, it's just a some number and it's followed by a 1. So it's just a 1. I think it was a mistake anyway. So I'm just going to remove this here. All right. So now we're done with S2. Okay, let's figure out what S3 is in here. So S3 gives me an error when it's a 1 and whenever it's 0, so I'm done with that. And I'm going to go to S4. So S4 has an error when it's a 0. What about if it's actually a 1? Technically, 1, all I have to do is just remember that it's a 1, and I think S4 is fine. So for this particular case, I'll just say, well, let's do 1, and the output is 0. All right, so let's say S5 in here. Okay, it tells me if the output is 1. What about if the output is 0? If the output is 0, I just want, like, well, the first one is 0 followed by 0. Well, I can technically just go in here all the way to S1, and S1 just remembers it's a 0. So I can say 0, and the output is 0. And at this point, I'm done with this particular finite state machine, and you can just go ahead and test it with the sequence that we've done in here. You can test it with the sequence, and hopefully you'll get these two ones that we've seen, this one in here and this one in here. Of course, if you want to implement this, you can either go to Vivado and just or write Verilog description for this particular state diagram, and you get the CAD, Vivado, or Quartus actually to do that for you. Or I can just go by hand and just go through state table, and then deciding that I'm going to use D flip-flops and some K-maps, and then from there I can go and just like figure out the inputs for the different flip-flops. And frankly speaking, because I have 5, that means I need, well, I have 5 states, so that means I need 3 flip-flops and an input. So I need something that is 4 variable K-maps at the output. And of course, because we're having mealy outputs as well, so it's like that mealy output, meaning this input here, X, should appear in Y. Like if you're actually writing Y, it should have like some X in it. And that's up to you, of course, which implementation you want to decide or implement.